Alright, this video is for chapter 7, number 42, in which you've got an arrow being shot at an angle above the horizontal. It's got initial velocity, and I hit a target. The question is, what's the maximum height the arrow will attain, and want to know how far away from the arrow the target is. Let's go ahead and draw a little diagram here. So basically we've got this. So we've got this arrow being shot at an angle, and the angle is 30 degrees, and it's got an initial velocity of 49 meters per second. Alright, so this is a motion in two dimensions, so we're going to break this up into our two different components. We're going to say our x direction, and we're going to say our y direction. Alright, so the things that you could know for x and y, we could know distance in the x direction, we could know my velocity in the x direction. It's not really important to make a distinction between initial and final velocity in the x direction because the velocity in the x direction is not going to change. So you could either call this initial velocity in the x, final velocity in the x, or we could just say velocity in the x. Because we're going to solve for an initial velocity, let's just go ahead and call it initial velocity in the x. You could also look for time in the x direction. So those are the three variables that basically you're going to worry about in the x direction. But just remember that the initial velocity in the x direction is going to be equal to the final velocity in the x direction because we're not accelerating or changing speed in the x direction. It's going to be constant. So these would be equal to one another, or we could just say velocity in the x direction if you wanted to. So just make sure you keep that in mind. Alright, for the y, it's a little bit different because we have gravity pulling down on things, so we do have a change in speed. So the things that we could know for y, we could know an initial velocity in the y direction, we could know a final velocity in the y direction, we could know the acceleration in the y direction, excuse me, we could know the distance in the y direction, and we could know the time in the y direction also. So the thing that's going to link these two variables together is our variable of time. The amount of time something goes in the x direction is equal to the amount of time it goes in the y direction. So if we can find t of x, or t time in the x direction, we know what the time in the y direction, or vice versa. If we find this one first, that automatically tells us what the x direction time is. So let's go ahead and find out some things. So here we've been given an initial velocity of 49, but this is going to be the resultant vector. So I need to break this down into its x and y components. So this component here is going to be my initial velocity in the x direction, and this component of the triangle here is going to be my initial velocity in the y direction. So let's use some trigonometry to find out what these two variables are. So if I want to solve for my VIY first, and referencing the angle, I've got my opposite side over my hypotenuse. So opposite over hypotenuse, that's going to be sine. So I'm going to say sine of 30 is equal to VIY divided by 49. So if I solve this out, I'm just multiplying each side by 49. So multiply this side by 49, so my 49s cancel out. So I'm left with VIY is equal to 49 times the sine of 30. So after I do that calculation, I find out that my initial velocity in the y direction is going to be 24.5 meters per second. And make sure that your calculator is in degree mode and not radian mode. Alright, so I can go ahead and put this number 24.5 in over here. So my initial velocity in the y direction is 24.5 meters per second. Alright, now let's go ahead and solve for my initial velocity in the x direction. So once again, I'll use trigonometry, but this time I have the adjacent side. So I've got the adjacent side over the hypotenuse, so that's going to be cosine. So I'm going to say cosine of 30 is equal to my initial velocity in the x direction divided by my 49. So once again, I'll multiply each side by 49, and then after I solve this, I'll get an initial velocity in the x direction to be 42.4 meters per second. And now I can go ahead and put this number in under my x. I'm going to say 42.4 meters per second. Alright, so now the next thing I'm going to solve for, well, let's see, is there anything that I know here? Well, I know my acceleration in the y direction is always going to be gravity, so I'm going to say negative 9.8 meters per second squared. And this negative just denotes that it's in the downward direction. So the first question asks, what is the maximum height? So if I were to draw out like a trajectory that this arrow is going to go, so I'm going to shoot it at some sort of initial angle, and it's going to make an arc in the sky, and then it's going to hit here. But if I go to the middle of this, from here to here, as I throw something up in the air, it starts to slow down because gravity is pulling down on it. Well, the velocity will continue to decrease until it hits 0. So at 0, this object is at its max height. So that's what we're going to reference here. So we're going to say the final velocity of this in the x direction, or the y direction rather, is going to be 0 meters per second. That's going to tell us the height at which this object goes. And that's the first question that it's asking, is what is the maximum height that the arrow reaches. So we're going to reference that. All right, so now let's see if we can solve some things to get down here. So I've got initial velocity, final velocity, and acceleration. Well, I know if I use this formula, acceleration is equal to final velocity minus initial velocity divided by time, I can go ahead and solve for my t here. So my acceleration is negative 9.8 meters per second squared. My final velocity was 0. My initial velocity was 24.5 meters per second, and I'm going to solve for time. So after I solve this equation, I'm going to get a time of equaling 2.5 seconds. So I can take this 2.5 seconds and put it in here. 2.5 seconds for time in the y direction. Now remember, time in the y direction is equal to time in the x direction. So I'm going to say my time in the x is 2.5 seconds also. Alright, so now let's go ahead and see if we can solve for the distance in the y direction. So let's use this formula. Distance is equal to initial velocity times time plus 1/2 at squared. And remember, this is all going to be referenced in my y direction because I'm just looking for y's here. So my distance in the y direction is equal to my final velocity or initial velocity in the y direction, which is 24.5. So I'm going to say 24.5, and then my time we said was 2.5 seconds. So I'm going to multiply this by 2.5 seconds, and then I'm going to add that to 1/2. My acceleration was negative. Don't forget the negative. Negative 9.8. And then my time, once again, was 2.5. So I'm going to say times 2.5 squared. Alright, so this expression here, after I solve everything for d, I'm going to get a distance to come out to be 30.625 meters. So this number goes up here for distance in the y direction. So I'm going to say 30.625 meters. Alright, so now I've pretty much solved for everything I can in the y, and this is going to be the answer to the first question. So the first question, once again, asks, what's the maximum height the arrow will attain? This is going to be your answer because this is your distance in the y direction. The next question says, how far away is the target? We want to know how far away is the target here from where I initially shot. So I want to find the distance from here all the way over to here. Now keep in mind, whenever we put 0 in for my final velocity in the y direction, I'm only looking at half of this. I'm only looking at this particular point. Okay, so when I solve for this distance, I'm only going to get the distance from this dot over to this dot. So make sure when you do find this distance that you double it to get the total distance from the first one over to the second one here. But anyhow, let's use this formula. So distance is equal to velocity times time. So my distance is what I'm looking for. My velocity was 42.4 meters per second. I'll leave the units off just for simplicity. And my time was 2.5 seconds. So when I multiply those two together, I'm going to get a distance of 106 meters. 106 meters. But now, like I said, 106 meters is just going to be your distance from this one to this point. So the question is asking how far away is it total. So we need to find from here all the way over to this one. So I'm going to take my 106 and just multiply it by 2. So when I take that and multiply it by 2, I'm going to get 212 meters, which is going to be my answer to the second part. That's how far away the target is from the arrow.